Okay, last one for today, the root test. So 9.6 has the ratio test, which is widely used for a lot of things, but there are times when the ratio test is going to be rather inconvenient and long to calculate, where the root test can kick in and work really well. It has the same outcome conditions. If you're taking the nth root of something, if the nth root is less than 1, it will converge absolutely. If the nth root is greater than 1 or infinite, it will diverge. And it's inconclusive if the nth root is exactly 1. So 3a and b are about doing the problem with the root test and doing it with the ratio test. So let's look at 3a and how it works. It says determine the convergence or divergence of the sum from n equals 1 to infinity of e to the 2n over n to the n. Now, you could do this with the ratio test, which we'll do in a second, but all the nth root test says is take the limit as n goes to infinity of the nth root of this thing, e to the 2n over n to the n. Just take the nth root of it, of the absolute value, but this is all positive. So the nth root is going to cancel out the n power, so this is the limit as n goes to infinity of e squared over n, which is e squared over infinity, which is 0. And so all you have to do is say by the root test, the series converges absolutely. It's really that simple. It doesn't widely apply as easily. For example, try taking the nth root of n factorial. There are some arguments you can make about it, but it's not that simple. If you see factorials, you almost always want to use the ratio test. So let's see what this would look like if we were using the ratio test instead. It would become the limit as n approaches infinity of e to the 2n plus 2, because when we have an n plus 1 in there, it'll get doubled, over n plus 1 to the n plus 1 divided by e to the 2n over n to the n, which again, it always turns into multiplication, e to the 2n plus 2 over n plus 1 to the n plus 1 power times n to the n over e to the 2n. Rearrange to get my terms I'm going to combine together, e to the 2n plus 2 over e to the 2n times n to the n over n plus 1 to the n plus 1. E to the 2n plus 2 divided by e to the 2n is just e squared. This we talked about. Pull the n plus 1 out. And then we have n over n plus 1 to the n power. Pulling one of the n plus 1s out, so there's only n of them left, and then I'm putting them together. So this is the opposite of the one we saw before, which was e. So this actually ends up being 1 over e. It's kind of bad form, but this is 1 over e, which means as n goes to infinity, this is e times 1 over n plus 1, but we know as n goes to infinity, this is going to be e divided by infinity, which is 0. So we still could have concluded the same thing. But you can see how much easier it was to do the other way. Now, this is our last set of tests. So the rest of your homework up there, pages 4, 5, and 6, We're using whatever tests you can, so trying to figure out how you pick which ones. Some questions to guide you, and the last page is all of the tests and what they can help you determine. So I would look at that chart, and try to use that if you're rusty. I know it's been 2.5 weeks since you probably thought about this, but this will conclude 9.6 and the notes for today. See you next time.